As you can see, in this next video, I've erased all of these other operators because we still need to talk about the triple bar here, the P triple bar Q. And I actually need the space to show you how we're going to be able to come up with this truth table for this particular operator. So we have P triple bar Q, and we might remember here that P triple bar Q means, maybe I'll just try and squeeze it in down here. It means if and only if. If and only if. And so P triple bar Q means P if and only if Q. P if and only if Q. Now if we break that down a little bit, right, we're talking about an and here. So we're talking about P if Q and P only if Q. That's what P if and only if Q means. It means P if Q and P only if Q. So all I'm doing here so far is just thinking about what does a triple bar mean? It means P if and only if Q. Well, that means P if Q and P only if Q. And the reason I'm doing that is because once I have it like this, I can actually translate, basically doing what we did in 5.1, translate that into symbols up here, and then kind of process what we have. So P if Q means Q horseshoe P, and, so that's the dot, P only if Q, which of course is P horseshoe Q. And so I'm hoping we can all recognize that these two statements are equivalent, right? This turns into this and vice versa. By the way, that's a point that I'll come back to in 6.4. So we'll come back to this, just make a reference here, and I'll mention it as well when we look at 6.4. Nonetheless, why I did this is because, well, it's hard to wrap our minds around if and only if, right? And think about, oh, if this is true and that's true and so forth, because we don't use if and only if very often in our everyday lives. If we can turn that into this, and then we can use the propositional operator, the truth tables that we just developed in the last video, we can actually process this. So one thing to recognize here, and this is part of 5.2, is to recognize that under this dot is our main operator for this. And this also helps us to think about the order of operations here. Once we identify the dot as the main operator, that's going to be the last thing we work out for this statement, because that's like our final answer. That's the truth value for this whole statement. And so what we can do here is we can look at the first row where, actually, let me go ahead and use a different color here. Q is true and P is true, right? Just pulling that from this pool of values over here. P and Q are true over here. So we're going to save the dot for last, meaning we can work on these other horseshoes here first. True, horseshoe, true, right, is what we're thinking about here. And this is where the truth table for the horseshoe comes in. True on the left, true on the right gives us true. Well, then that's true over here as well, right? True on both sides. Now, in terms of the order of operations here for this, it's always the last thing we did on the left combining with the last thing that we did on the right to that main operator there. That's the order of operations. So start with the individual statements here, P and Q. They combine, and then those combine to the main operator. So what we're looking at here is true dot true. True dot true. So we need to use the dot truth table for that logical operator. And when we have true on both sides, remember, we said that was true. In the second row here, it looks like Q is false, P is true, Q is false, and P is true. And so what we're dealing with here is false, horseshoe, true. And so we use the truth table that we had on the previous video. False feeding into it from the left actually gives us true here. But, and this is the important one, true, horseshoe, false, right? Let me make this order of operations a little bit more here, perhaps. True, horseshoe, false is the one and only way to make the horseshoe false, right? So remember that. True on the left, false on the right makes the horseshoe false. So then what we're dealing with here for the dot is true dot false. True dot false is false. Go to the next row. P here is false. Q is true. P is false. Q is true. Just grabbing those from over here. So now we're looking at true horseshoe false. True horseshoe false. By the time the exam rolls around, you want to be at a place where you know true horseshoe false automatically. Yes, false. False horseshoe true. True. So we're looking at here, false on the left, true on the right. Gives us false underneath the dot. And so then we come finally to where P and Q are both false down here. So what we're looking at is false, horseshoe false. That's actually true. False, horseshoe false is still actually true. And so now we're looking at true dot true. Right? The last thing we do on the left combines with the last thing you do on the right. And true dot true is true. And so what we can recognize is that if the triple bar turns into all of this, and then the main operator column is true, false, false, true, well, then we get true, false, false, true here. And I'm hoping in breaking down the triple bar in this way, you can see where this comes from, right? This is why we get true, false, false, true. It's because the triple bar turns into this, and we can see where that column then comes from in terms of these individual pieces here. So when it comes to memorizing the truth table for the triple bar, though, I will just observe that this one's not so bad. Basically, all you have to remember is that when both sides, we can fill in the blanks here. I will say before I do that, when it comes to the quiz on this material, all you need to give me is you'll need to write down this pool of values here for your P and your Q. And then if you just go through and write down the main operator columns for each of those operators, that would be fine. You don't have to go in like we saw in the previous video and put the true, false on either side. I will do it here just so we can kind of follow this. What I have just said is that you don't actually have to give me this as long as you give me the pool of values over here. Just give me the main operator column and you'll be fine. So how does a triple bar work? When both sides are true, it's true. And notice this. When both sides are false, it's true. So the way I think of the triple bar is when they're the same, it's true. When they're the same, it's true. And when they're different, it's false. Different, it's false. Right? So same is true, different is false. That's how the triple bar turns out that way. And you'll need to memorize that along with the others for our quiz on this material.